it's Michael here, and in this video, we're going to look at dimensioning using the Revit API. And in fact, we're going to look at two ways that we can do dimensions. We're going to look at dimensioning using element faces, and then we're going to look at dimensioning family instances and how we can use this pretty clever little hack in order to dimension to various reference planes. So we're going to get into a lot, deal a lot with geometry, get into some of the good sticky parts of dimensions. So before we take a look at the code, let me show you what the final add-in is going to look like. So I'm here in Revit in my sample file, and you can see it's a real simple model. I've got 4 walls, I've got a few doors and some windows. So our add-in is going to dimension the wall, and it's going to dimension the elements inside of the wall. So we're going to be looking at dimensioning across different categories. So I'm going to go up to add-ins, and I'm going to run our add-in right here. I'm going to select the wall. And when I do that, you'll see it automatically dimensions from the ends of the walls to the middle of these families inside the wall. And then it gives us an overall dimension as well. And it did it super fast. So I can go here, I'm going to dimension the other wall. Let's get the walls down here on the bottom. You can see when there's no openings, it just runs one dimension string. And then we'll get this side as well. Now, one thing to note, if you look here, it's not dimensioning kind of to the end of the building. It's actually dimensioning to the end of the wall. So it's taking into account the wall join, and which may or may not be desirable. But in this case, it's dimensioning sort of the extents of the wall, and that's what it's using in terms of the reference points for the dimension. Now, I'm going to undo these real quick, and then you'll notice too, if I make a change to the wall, let me say I'm going to make this an angle here, and let me trim it, and I'm going to run the tool again. What you'll see is that the dimension obviously follows along that direction of the wall. All right, so let's switch over into Visual Studio and let's start coding. So I'm here in Visual Studio, and as you saw in that quick demo, the first thing we want to do is prompt the user to select an element, to select a wall. So I'm going to drop my code in here, and we're going to use the selection class in order to prompt the user to select an object. Basically, this will be a wall. So we're going to use UIApp.ActiveUIDocument.Selection and then the pickObject method. This method has 2 arguments. The first is what we're going to pick, and in this case we're going to pick an element, and then a prompt for the user, and we're just going to tell them to select a wall to dimension. Next, we're going to use the returning reference from the selection method to get the actual element. So I'm going to use doc.getElement. I'm going to pass in the reference variable that we got in the line of code above, and that's going to give us the element object. Now, once we have that element object, we can go ahead and we can get the wall from it. So what we will do is we're going to do a quick check here, and I'm going to do an if statement. I'm going to say if selected element is wall, then we're going to continue with our code. And if it's not, we'll do an else, and we'll say we'll return result failed. So in that case, the user didn't select a wall, so we don't want to continue, and we can't dimension something that's not a wall using this method. Okay, so if we are confident that we have a wall, we're going to go ahead and we're going to cast our element here, the selected element, as a wall. And so we'll create a wall variable called selected wall. So now we're ready and we're good to get started. Now I'm going to create some other variables. Now one of the first variables I'm going to need to create is a reference array. And a reference array is, like it sounds, it's an array of references. So we're going to use this reference array and we're going to pass this into our dimension method. And this is going to contain all of the a reference to all of the elements that we want to dimension. Now we're also going to create 2 references initially, and we're going to use those to get our wall edges. So I'm going to go ahead and I'm going to pass those in, and we'll use those shortly in a second. Now with this method, what we're going to do is we're going to look at the wall geometry, and we're going to use that wall geometry, specifically the faces of the wall, in order to get the pieces that we want to dimension. And in fact, we're going to get the wall face, and then from the face, we'll get the edges that make up that wall. So we're kind of breaking down the wall into its more kind of fundamental geometry, and those are the pieces and parts that we are going to dimension. Now, we're going to use a method here. Let me create the variable. So ultimately, we want to get the face, and then from the face, like I said, we're going to get the edges. So we'll create a variable for the face, and I'll call it wall face. And I'm going to set that equal to a method called getFace, which I'm going to create in a second. Now, in order to get the face, we have a lot of different faces around the wall. We have the sides, we have sort of the ends, we have the top and bottom. So we're going to pass in two things. We're going to pass in the actual wall itself. So we're going to pass the selected wall variable, and then we're going to pass in the orientation of the wall. So the orientation of the wall is a vector that describes sort of the direction in which the wall is facing. And typically by default, that orientation of the vector is going to be facing towards the outside of the wall. Now that orientation property is just a property of the wall class. So I can just type selected wall orientation. And so that's going to get me what we need. So I'm going to right click here. I'm going to go to quick actions and refactoring, and we're going to generate that method getFace. So within our getFace method, we're going to do two things. We're going to get basically the solids of the wall, and then we're going to iterate through that wall solid and sort of take it apart. So we're going to create in our getFace method, we're going to create a variable called planar face, and we're going to set that equal to null. And now we're going to get the solids for our wall, and I'm going to just use a generic var variable, and I'm going to call it solids. I'm going to set it equal to another method I'm going to create called getSolids. And for solids, I'm going to pass in the element. In this case, it's going to be our selected wall. And in this case, we'll keep our variables here. Actually, I'm going to change this for getFace. I'm going to make this more generic, and we'll set this to be an element, and we'll call this selected lm. I think that will work, and then same thing we'll pass in to getSolid selected lm. Okay, so now I'm going to right click here. We're going to create that getSolids method, and for getSolids, again, we're passing in an element, and we are going to create a list of solids that we're going to return. In most cases, our elements are going to return a single solid, but there could be instances where we have multiple solids. So we're going to return a list. Now we're going to create an options variable. And we're going to need this once we get the solid geometry. So I'm going to create an options variable called options. I'm going to set it equal. I'm going to create an instance of it. So I'm going to set it equal to new options. And then I'm going to set two properties in this. One is compute references. I'm going to set that equal to true. And then the detail level. So I want to, when we get the geometry, I want that detail level to be fine. So we're going to get all the geometry. Now, once we've done that, we can actually get the geometry element. So I'm going to create a variable called geometry element. And doing this is kind of like peeling an onion. So we're going to get the geometry element. Then from the geometry element, we're going to get geometry objects, and we're going to check those objects. So we're kind of working our way through the hierarchy from geometry element to object to the solid. So we'll call this geom lm, and we're going to set it equal to our selected lm dot get underscore geometry, and then we're going to pass in the options variable. So this is going to give us the geometry element for that particular element. Now we're going to iterate through the geometry element, because again, there could be multiple pieces of geometry in here. We're going to look at each geometry object. We'll call this geom obj, and so we're going to iterate through the geometry objects in our geometry element. And we're going to check to see if this current object is a solid. So if it is a solid, first we're going to cast it, and we're going to cast that geometry object as a solid. And then we're going to just check Yeah, we want to make sure its volume is bigger than 0 and its size, the number of faces are greater than 1, just to ensure that we have something that's actual, that's going to be useful. So I'm going to do an if statement. Let me scroll up a little bit here. I'm going to say if solid.faces.size is greater than 0 and solid.volume is greater than 0.0, because that volume is going to be a double. So we're looking at the faces, which is a face array. So we want to make sure there's more than 0 faces and that the volume is greater than 0. So that's actually geometry. All right, so if this is the case, what we're going to do is then we're just going to add that solid to our return list. So we'll do return list.add. Oops, let me get that typing right. That's better. We're going to add that solid. So we're going to iterate through all of the geometry objects. If they're solids, we're going to put them in this solid list. So once we get through all of that, then we're going to just return our return list. Just like that. Okay, so now going back to our get face, we start our get face by getting the solids. Once we have the solids, we can iterate through those. So we're going to do a for each solid in solids. And then within the, oops, again, a typo. Let's try that. And let's see, it's giving me, okay. It actually doesn't, let's be a little bit more specific. I'm going to say this is our list of solids, okay. And then we'll be explicit in here for each of our solid. There we go. Okay. No need to get cute with our var statements there. So now for each solid, we're going to iterate through all of the faces. So for each face, we'll call it face in solid.faces. So we're getting that face array for the solid. And now we're going to check and say if face is planar solid. So if it's a flat solid, or sorry, planar face, yep, like that. Now we're going to cast that face as a planar face, and we'll call it PF is equal to face as planar face. So again, we're getting more specific. So now the last thing what we want to do is we want to say if PF.faceNormal is almost equal to our orientation. So if the normal of that face is almost equal to that wall orientation, that's going to give us the face we want, which is basically going to be our exterior face of the wall. So if that's the case, then we can just return our planar face. Or actually, you know what I'll do instead? I'm going to set, we'll set return face is equal to planar face, okay? And then here at the very end, we'll just return face, just like that. Okay, so let's see, we have an issue here. Let me fix, oh, there we go. Get solids. This is going to return a list of solids. So I'm getting everything all set up. Okay, so that gets rid of that error. So get solids looks solid, and then get faces looks good as well. So at the end of this, once we select our wall, we create our reference arrays, our references, then we can go ahead and get the face for that particular wall. So once we have that face, we're getting there, we're stepping through. So what we can do next is we can iterate through the faces to get the edges. And again, ultimately what we're going to dimension are the edges of that face. So now we're ready to iterate through all of the edges in the face. So we have the face here. I'm going to go ahead and I'm going to create a couple of things. I'm going to create an edge array, which is a very strange class in the Revit API. It's essentially, it's an array of edge arrays. Go figure. And we'll work through this in a second. So I'm going to call this edge arrays. I'm going to set it equal to our wall face dot edge loops. So if you think about taking a face from a wall, if that wall has openings, we're going to have multiple sets of edges. We'll have the overall edge around, the edges around the wall, and then each opening is going to have a series of edges as well. So that's why we have this edge array. So a wall that contains one window is going to have two edge arrays, one for the exterior edges of the wall, and then the second for the window edges. So depending on kind of the complexity, we could end up with multiple edge arrays. So edge loops is going to get us all of those edge arrays. Now we're also going to create just an edge array, and I'm going to call this edges, and I'm going to set that equal to edge arrays dot get item, and we're going to get item 0. So the first edge array is actually going to be describe the extents of the wall itself. And all the subsequent edge arrays are going to be any openings that are within it. So that's why we can be pretty well assured that that first edge array is going to be describe kind of the exterior, boundaries of that wall. Let's see, we've got an error here. Let's object reference. Okay, edge array. Oops, sorry. I was calling the class, not my actual variable. So edge arrays. There we go. So we got rid of that. Okay, so now we have our set of edges. Now I'm going to create a return, like a list to keep my edges. And I'll do a list of edge, and we'll call it edge list. And this is going to be an empty list. And now I can iterate through those edges. So I'm going to do it for each edge, and my variable will be called edge in edges. So a lot of edges going on here right now. Now, for each edge, an edge is a special type or class within Revit. So what I want to do is I want to cast it to be a line. So I'm going to say line, and then I'll create lowercase line is equal to our current edge as curve. And then I want to cast this to a line class. So it's going to come out of as curve as an actual curve. I want to be more specific. I know it's going to be a straight line element, so I'm going to cast it into a line. And now I'm going to check it, and I'm going to say if, and I'm going to use a method I'm going to write in 1 second. I'm going to say if is line vertical. We're going to pass in that line variable as our argument. If that's equal to true, if it's a vertical line, then we're going to add this to our edge list. Now imagine within the edges that describe our wall, we're going to be dimensioning kind of the vertical lines across it. I don't care about the top and bottom. We're not looking in an elevation, we're actually looking in a plan. So we want those side edges, which are really the vertical edges for the wall. So that's why we're going to do this check right here. All right, so we have all that set up. Now I'm going to create this method here, isLineVertical. So I'm going to generate that method. So for the isLineVertical method, we're going to check, and I'm going to do an if statement. I'm going to say if our line dot direction dot is almost equal to, so we're going to check the direction of that line, and we're going to see if it's almost equal to XYZ. We're going to use the XYZ class dot basis Z. So we're saying, is the direction of the line, which is a vector, almost equal to the basis Z vector? So if that is true, and then we're also going to check, because a line could be, sort of direction could be up, and it could also be going down. So I'm going to do the opposite. I'm going to say, or if line dot direction dot is almost equal to, and we're going to do negative XYZ basis Z. So if the line direction is either pointing up or the line direction is pointing down, then we are going to return true. If not, we're going to return false. So that line is not vertical if those conditions are not true. Okay, so real quick check that we can do it, and we're going to use that basis Z because we know that's going to be our vertical direction. So going back into our loop, if that is the case, if the line is vertical, we're going to add that to our edge list. So those are going to be the vertical edges that we want to dimension. Now I could go ahead at this point and I can run my I could go and I could actually, build out my reference array and dimension the element right from here. Now, what I want to do though, in this case, I want to kind of dimension my wall ends, and then I'm going to dimension the actual family instances that are inside of that. If I were to stop my add-in and basically build out my dimension right here, I would be dimensioning kind of the openings as we go across the wall. So I would dimension the wall end, both sides of the door, and then both sides of the window, so on. Now, the method we're going to use, it'll be a little different because we'll have flexibility, and we can decide if we want to dimension to the center of the window or to the left or right. So it's a little bit more flexible. So with that in mind, what I really want to do using this code here with the edges is I want to get the sort of the beginning and the end edges of the wall. That's all I really care about. So to do this, I'm going to first sort my list of edges. And I'm going to use a little bit of link to do this. So I'm going to create a list of edges called sorted edges. And I'm going to set that equal to, and I'm just going to drop this in right here. So we're going to use link to do this. And we're going to order our edge list. We're going to order by descending. And we're going to get the curve of each edge. We're going to get the length of it. And then that's what we're going to use to do our ordering. So rather than getting the edges in order as they occur, we're going to get them from tallest height to lowest. So I know based on the way that the wall is constructed in the wall face that the ends of the wall are going to be the longest, and any openings that are inside the wall, those edges are going to be a lot shorter. So I feel pretty confident based on the way a wall is built that this is going to give me those two ends, or it's going to at least give me the order from which I can get those ends. So now, with this order, what I can do is I can create my two references. And up here, I've defined the variables R1 and R2. Now, right here, now that I have that sorted list, I'm going to reference sorted edges, let's change the name of that. I'm going to reference, sorted edges, item 1, and then item 2, and that's going to give me the tallest parts, vertical parts of the wall. So that's what I'm going to use to kind of dimension the extents of the wall. Now that I have these items, I can go ahead and I can add them. I have those references. I can add them to my reference array. Now, I do want to be particular. I want to put these reference arrays kind of in the order in which I want to dimension them. So I'm going to go ahead and I'm going to reference our reference array, and I'm going to use the append method, and I'm going to first append R1, which is going to be the first part of my dimension. Now that I have that, I can start working on getting those elements that are inside of the wall. So to do it, in this example, we're going to look at dimensioning walls and doors. So I want to kind of do a filter of those elements from within the wall. So first I'm going to create a category list, and I'm going to use that to create the filter. So let me set this up. So I have a list of built-in categories called cat list, and inside of that I can put these on the same line. I broke them into two lines, but let's put them up here so we can see it. So we've created the instance of the list, and then I've added our built-in category windows and doors. So we're going to use that as our filter. And with that list, we're going to create an element multiple category filter. It's a mouthful. So this filter, we're going to call it wall filter, and it's going to contain those two categories. And we're going to apply this in 1 second, because what we want to do is we want to use that wall. We want to get the dependent elements from that wall, but we want to filter them specifically for windows and doors, because those are the things that we want to dimension. So we are going to use that too to basically get our references. So this is accomplished using the method getDependentElements. So this is part of the element class, and it allows us to get the dependent elements from an element. In our case, we have a wall, and hosted within it are windows and doors, and could be some other stuff. So we're going to use that getDependentElements method, and we have an argument here that we can pass in a filter. So we're going to pass in our element multi-category filter. So we're only going to get the dependent elements that are of the window or door category. So we can really narrow that down. So we have our list here of element IDs. Then we reference our get dependent elements from our selected wall. And this, we're going to return this to a list. So it's going to give us a list of element IDs. So now with this, we have all the stuff. So we have the wall, we have the edges of the wall. Now we have the elements, the windows and doors inside that wall. So we're going to loop through those items. So for each element ID, and we'll call this, we'll just call LMID in our wall elements ID, okay? Now we're going to create basically we're going to cast that element ID into the element. I know it's windows and doors, so they're going to be family instance class. So I'm going to create a family instance. We'll call this carFI. We're going to set it equal to doc.getElement. And then we're going to pass in our LMID. And we're going to cast this as a family instance. All right. So now that we've got that, we have that actual family instance. And from here, we can get a reference to the element so we can actually dimension it. Now to get that reference, I'm going to create a reference variable, and we'll call it carref. And I'm going to set it equal to a method I'm going to create, which is called get special family reference. And we're going to pass in our current family instance, as well as something we're going to create in a second. So I'm going to leave that argument blank for right now, and then we're going to actually create this method itself. Now this is a method that I was fortunate enough to find on the internet, and it's super interesting because it uses a bit of a hack in order to get the reference from the family instance. Now there's kind of a couple parts to this. The first part is that I need to create an enumerator. And this is going to identify the special reference type. So I'm going to paste this into my code right here. And an enumerator is really just a list of predefined elements. So I have the enumerator called special reference type. And you can see there's different kind of references inside of this. Left, center, left, right, front. And they all have a number associated to it. So when I go back to my method here, what I can do, in addition to passing in the family instance, I want to pass in my special family reference type. So to start, we'll use that, where is it? Here we go. We'll use center, left, right. And then down into my method here, I'm also going to create an argument for our special reference type. We'll call it ref type. Okay, so that's our method, and I'm going to paste this in its entirety, and we'll walk through it. And the source code, I also have a link to it if you want to read through it. Again, it's a very interesting method, and it's not small. So let's drop that in. And again, I'll walk through it. Hopefully I got that in. I think that looks okay. We'll fix these errors in a second. I'm probably missing something. Okay, so it looks like it added a namespace when we did that. So let's get rid of some of these namespaces. That's it right there. That should fix all those errors, I think, or most of them. So let's scroll back down. Here we go. So what this method does is we have the family instance. And let me just check and make sure. I'm going to change my argument name here just to match. And I do recommend, if you want to read more about this, check out this link here. And again, this was the secret to this. It's called Stable Reference String Magic Voodoo. And it is Magic Voodoo. I totally agree with that title. Basically, what we're going to do is we're going to go through the instance. We are going to get the geometry of it. Now, with a family instance, it's a little bit even more like an onion because we first get the geometry element, then we get the geometry object. And this method has some kind of layers to it in here as well because we're dealing with a geometry instance too. So from the instance, we go ahead and then we can get the element and then the object. So there are different sets in here, ultimately, based on that type of geometry. Is it a solid? Is it a curve? Is it a point? Ultimately, what we're doing with this code is we're getting the stable representation. So we have a variable called sample stable ref, which is just a string. Now, inside of Revit, we have these stable representations, which is actually a string that includes a unique GUID, as well as some other characters as well. And that allows us to get two elements in a particular way that it's not going to change. Now, element IDs we know will change and can change, but the stable reference is just that. It's stable. It's not going to change. So we can have a pointer to an element that will persist throughout the life of the model. So in all of this code, what we're doing is getting the geometry, and then we're getting the stable reference to it. Now, once we have that stable reference, we're actually going to parse it. We're going to break it down, and then we're going to put it back together. And at the very end of that stable reference, we're going to input a integer that relates to these special reference types. So we're pointing to a stable reference to that family instance, the geometry of it, and then we're identifying, which reference plane do we want? Left, left, right, right, front, center, front, back, back, bottom. So that's allowing us to specify within that family instance where we want to get the reference, which is great for us because in our add-in, we want to dimension it to the center of our doors or our windows. So at the very end of all of this, again, we're rebuilding that stable reference by strings, taking the original stable reference, then we're parsing it, and then again, getting that stable reference itself. So at the very end here, once we finally have put that stable reference string back together, we're using this reference parse from stable representation to get the actual reference object. And that is what we're going to use all the way back up here in our code. So we're getting a reference to that family instance, and we're also getting it to the reference plane that we want. So now, again, as we're iterating through all of these elements, depending on elements, hosted elements inside the wall, we're getting the reference to them. And then now we can put that reference into our array. So I'm going to say our reference array. Oops, let's try that again. And we're going to append our car ref. And we'll go on to the next item and the next item and the next item. So once we've done that, you can see it's actually not a whole lot of code. There's a lot of code getting that special family reference. But once we have that, it's pretty streamlined. So we've gone through, we've added all of our references. The last thing we're going to do is we're going to add that end wall edge. So I'm going to reference array.append, and we're going to do R2, which is going to be, again, that last edge. So now that we have all of that set up, we can go ahead and we can create our dimension. To create the dimension, we're going to need to provide three pieces of information. We're going to need to provide the view we want the dimension to reside in. We're going to need the reference array, so all the references we want to dimension. And then we also need to provide the dimension line. So where in that view is that dimension string going to be located? So we can go ahead here and just rough out that code. So we're going to create a dimension, we're making a change in the model. So we're going to need a transaction. So I'm going to create my transaction. Our new transaction, and then we're going to create the transaction in our document. We're going to start the transaction, and this one we're going to call create new dimension. Okay, so that's good. Now at the end, obviously we're going to commit that transaction, commit it to the model. So right here we can put our dimension, new dimension code. So I'm going to create a dimension variable. I'll call it new dim, and I'm going to set that equal to doc.create, and we're going to create a new dimension. And the new dimension, again, our view is going to be our doc.activeView. we're going to then use as our dimension line, I'm going to just put in a variable here called line, which we'll create in a second. And then the last thing is going to be our reference array. And that's all we need for our dimension. It's pretty straightforward. So to create the line, what we're going to do is we're going to base that off of the wall that we have selected. So we're going to, let me put a little bit of space up here, and we'll put in our create dimension line comment. And to start with this, we're going to take the location curve of our wall. And we know because a wall is line-based, we know that it's a location curve as opposed to a location point. So we create our location curve variable, and we're going to set that equal to selected wall.location as location curve. Now from that location, what we can do is I'm going to create a line variable called wall line, and that's going to be equal to our wall loc variable dot curve. And we want this actually as a line, so I'm going to cast it as a line. And again, I know it's a line because it's coming from a wall, and we're going to assume too that this is not a curved wall. So that gets us a line, and I could use this wall line right here in my dimension. That wouldn't be a problem, except excuse me, the dimension string would then reside right on top of the wall, and we want it to actually offset a little bit. And we want it to offset in the direction of the wall. So we're going to do a little bit of work here to create that line so that it's offset from the actual wall itself. So I'm going to create a couple of points. I'm going to call offset 1, and then I'm going to create another one called offset 2. And we're going to use these to actually generate that line. So I can now create a line variable. We'll call it dim line, and I'm going to set that equal to line dot create bound, and then we're going to use our offset 1 and offset 2. So this will ultimately be the line that we're going to use in our dimension. So we'll change that variable out like that. Okay, so right now we just need to figure out these offset points for our lines. So we're going to write a method here, and let me rough it out. It's going to be called get offset by wall orientation. And in this, we're going to provide a point, so a wall, an endpoint of the wall, and then the orientation of the wall, and then a distance. So in this case, we're going to take wall line dot get endpoint, and we're going to take 0, which will be our start point. We're going to get our selected wall orientation, and then we're going to offset it 5 feet in our case. And remember, we're entering a dimension here. In the Revit API, it's going to be decimal feet, regardless of if our model is metric or imperial. So we're going to use a fixed value right now of 5 feet. And then I'm going to do the same thing down below, except instead of our endpoint being 0, we're going to use endpoint 1. Let's get that set up. And right here, we'll add our equals. Okay, and then we'll just change that endpoint. All right, so we have all of that. Now we just need our get offset by wall orientation method. So let's use our quick actions and refactorings. We're going to generate that method. And for this, what we're going to do is we're going to look at that point, and we're going to use that point as well as the direction of the wall to kind of create the offset point. So this method is going to work by multiplying first the orientation vector. So we're going to create an XYZ. We'll call this new vector. And let me fix this up right here. So our XYZ new vector, and we're going to set that equal to our orientation argument dot multiply, and then we're going to multiply it by our value argument. So that distance. So we take the orientation, and we're going to multiply it by the distance that we're provided. So we multiply that. Next, we're going to create our return point, and that's going to be equal to, let's fix our argument name here, point. So we'll take point, and we're going to add our new vector. and then we'll return point. So we take the orientation, we multiply it by our value, then we add that to our point, and that's going to give us that offset distance. We can go back up here, so now we should be all set. We have our endpoints, we have our orientation, we have our distance, and that's going to create our line, which is going to be offset that specific distance. So let's switch over to Revit and let's give this a test. So here in my test file, I'm going to go up to add-ins, and we're going to run our add-in. And I'm going to go ahead and select my wall, and you can see it placed those dimensions right where I wanted, so exactly 5 feet off here. Now if I run it again, I'm going to choose this sidewall, and I can see those dimensions are coming in just like that. Now I could go into my code and I can change the location. Again, we're using that center left right for our placement of the or getting the reference plane, the center left right reference plane. If I go into my code right here, and let's go up to our special reference type setting, let's change that to be left, for example. And I'm going to do a hot reload. And let's switch back into Revit. And I'm going to pull this dimension up so we can see them at the same time. And we'll give this a run. And now you can see it's going to that side. And it looks like it's getting it. It's a little bit different too. It's not always consistent. But what I could do in my code is if I wanted to get the opening, I could actually set this up so that I would get both sides of the wall. So we have our reference carref. I'm going to add another reference here. We'll call this carref 2, and then we'll make our special reference type to be right. And then we're going to append both of these references. Oh, let's get that. Try that again. Reference array append carref 2. Okay, we'll give this a hot reload. So now when we run it, what we should see, and let's pull this up, is that it's going to get both sides of those families. Click on that. And then, yep, so I'm getting, either side of the opening. So depending on which reference I use and which one I specify, I can get really granular about how I want that dimensioning to occur. Now, one other thing that I showed in the demo at the beginning is I was giving it an overall dimension as well. So I'm going to go ahead, let me just change this back. I'm going to comment out that line. In fact, let's do this. We'll add this as we'll do some commenting out here in a second. So this is we'll set this one back to our center left right. Let's comment this out. Comment that out, and then we'll comment out that one. Okay, so to do an overall dimension, in addition to dimensioning all the openings, I'm going to go ahead and I'm going to add another reference array. So let's copy this, and you'll see we can accomplish this with very little changes to our code. All of the pieces are in place. We just have to add some additional elements here. So we're creating a new reference array. So now we're going down here and we're creating getting our references from the wall. So where we're adding that R1 reference, I'm going to go ahead into our new reference array, reference array 2, I'm going to append R1, and I'm also going to append R2. So we're going to add both of those references right here. And so when we create this second dimension, we're just going to reference those ends of the wall. Let me add a comment here, reference wall ends for overall dimension. Okay, so everything else is good. We're still going through this same process. Now our dimension line, we're going to need to create another dimension line. So we're going to create a series of additional offset points. So these offset points, we're going to use a lot of the same code. So let's do, actually I'm just going to copy this. And we're going to We'll call this offset 1B and offset 2B. All of this is the same, except we're going to change that offset distance. So instead of 5, we're going to go to 10. And then we have our dim line. We're going to copy this. We'll create dim line 2. And that's going to make use of offset, we're getting all of our IntelliSense, offset 1B and 2B. So now inside of our dimension, we can go ahead and create that dimension. Now, one thing we want, though, is if a wall doesn't have any openings in it, we don't want to add 2 dimensions, because the one dimension, the first dimension, is going to be the overall anyways. So I'm going to add an if statement here. And I'm going to say that if that wall element ID count is greater than 0, meaning that there are actual elements in the wall, then that's when we want to go ahead and add that second dimension. So if the wall element ID, if the elements that are hosted in the wall, if we find some of those, then we create that second dimension. And again, we can just use this code here inside our if statement. And we'll call this new dim2. And the only thing we're going to change is our dimension line, dim line 2 and, our reference array. These are all going to be dim line 2 and reference array 2. That's it. That's going to give us that overall dimension. So let me give that a hot reload. We can switch back into Revit. I'm going to select these dimensions and just delete them like that. And let's give it a test. So I pick my line, and you can see there's all of my individual dimension strings for those elements, and then our overall. And then we can go around here and basically just work our way around, and we're getting 2 dimension strings right there. And then for the remaining 2, we should just get that 1 overall. Yep. And same thing here. And the thing to note too is our dimension line is coming in, and it's orienting that line directly to the orientation of the wall. So we know that that code is working because we're getting the wall orientation and we're getting those offset points. All right, so give this a try. Let me know if you've run into any issues. But a lot of the principles, again, getting the edges from the face, that can apply to a lot of different things we want to dimension. If we wanted to dimension floors, roofs, so on. And then also with family instances, I could use that similar approach to getting that reference plane into dimension columns or furniture or anything like that. So a lot of the skills shown in this video, I think, will apply to a whole host of different options as far as automating dimension. All right, so give it a try. Let me know how it works, and good luck. Thanks.